Welcome to the Deep Dive. Today we're wading into a piece of writing that essentially asks you to throw out everything you learned in high school physics.
Yeah, pretty much everything.
Right. If you're joining us, I'm assuming you appreciate a good intellectual shakeup. You don't mind having your perspective tilted slightly off its axis.
You're definitely in the right place for that today.
Exactly. Our mission for this deep dive is to tackle a highly unconventional physics blog post that was actually just published today, March 7th, 2026.
Hot off the presses.
It really is.
Yeah.
The author goes by the handle Zynad 2023, and the piece is titled Draft Einstein's Slacking 114 Main Subject, Monitoring Brownian Motion from the Sky.
Which is quite the title.
It is, and it's less of a standard academic paper and more of a total paradigm shift wrapped in a really wild thought experiment.
It really feels like an earthquake aimed at the bedrock of modern science. To give you some context before we get into the weeds here, this material doesn't just nitpick a single equation.
Right, it's way bigger than that.
Much bigger. It goes after the fundamental ways human beings have perceived reality, space, and time for centuries. We are talking about dismantling the mathematical shortcuts we've relied on since René Descartes.
And perhaps the most jarring claim of all is that Albert Einstein himself made a massive conceptual oversight regarding the physical, messy reality of how light actually travels through space.
Yeah, questioning Einstein is always a bold move.
Okay, let's unpack this, because to even entertain these ideas, the text demands we completely rewire our basic intuition. The central premise the author is pushing is that we need to stop measuring distance in terms of physical space.
Like miles or kilometers.
Right, and start measuring distance strictly in terms of time.
Which is a huge mental hurdle to clear. To force that perspective shift, the text opens with a brilliant, highly relatable cosmic scale example. Think about standing outside on a clear night and looking up at the constellation Orion.
Specifically, the post targets the star Betelgeuse. When you look up and spot that bright red giant in the sky, the post points out a fact that we all sort of know, but rarely internalize.
We take it for granted.
Exactly. You aren't seeing Betelgeuse as it exists right in this exact moment. You are capturing light that left that star roughly 500 to 1,000 years ago.
It's staggering when you really think about it.
You're basically looking through a telescope into the Middle Ages.
What's fascinating here is how that single, universally accepted astronomical fact is used to establish a sweeping rule the author calls information delay.
Information delay.
Yes. The argument is that every single thing you observe visually is a calculation back from observation time.
The post actually includes a timeline graph illustrating that the visual world is just an accumulation of the past.
Exactly. And it's not just distant stars. The light bouncing off the coffee mug on your desk takes a tiny, almost imperceptible fraction of a second to reach your retina.
Because of that unavoidable travel time, the piece insists that true spatial distance doesn't actually exist in the way we think it does. There is only time distance.
So the concept of a perfectly synchronized present moment across the universe is essentially a hallucination.
We are all just living in a composite reality built entirely out of delayed information.
It's a heavy philosophical starting point.
It is, but it perfectly sets the stage for the post's main critique of classical mechanics.
It does, because classical mechanics relies almost entirely on ignoring that delay.
Which brings us to a really grounded analogy from the source. They talk about a Sarah plate.
Which is just a standard, everyday, circular dining plate.
Right. If you put a plate down on a table, basic math teaches you to mentally draw an XY axis over it, a standard Cartesian plane.
And once you map that mathematical grid onto the physical world, you can comfortably declare that the plate has a velocity of 0.
You could say it is perfectly stationary.
But that is exactly what the text considers a massive, unchecked philosophical cheat code.
A cheat code.
Yeah. When we project that mathematical grid, we are conjuring a non-material, totally abstract space. We are giving ourselves a godlike, infinite perspective that simply deletes the physical boundaries of our actual limited vision.
Because the grid assumes instantaneous synchronization across all points.
Right. It's a neat trick. It worked well enough for Descartes, it worked for Isaac Newton, and it was heavily utilized by Einstein.
That segues into a very specific historical application the post zeroes in on, which is Brownian motion.
All right, the jittering particles.
Exactly. For anyone fuzzy on the term, that's the chaotic, random jittering of microscopic particles suspended in a fluid. The text asks us to visualize a single pollen grain floating in water.
But it frames it with a mechanical analogy to help us picture the physics at play. The author compares the floating pollen grain to a single train car.
Okay.
And the fluid surrounding it is made up of countless invisible water molecules violently crashing into the pollen, causing it to bounce around erratically.
So those invisible water molecules are compared to the train tracks and the wooden ties beneath the train car. You've got it.
But wait, if I'm a 19th century physicist trying to study that pollen grain, how do I actually measure that chaotic bouncing without losing my mind? Don't I need that godlike mathematical grid just to make sense of the data?
Well, you do have to simplify reality to measure it, yes.
Right.
And that is the exact tension being highlighted here. To measure that microscopic movement, scientists construct what is called an abstract inertial frame.
An inertial frame.
Yes. It is a mathematical safe space where the observer, let's say the scientist looking through the microscope and the subject, are mathematically defined as having zero relative velocity.
So they are locked together in a state of perfect, synchronized stillness.
Exactly. But the text argues this is a profound error because it completely edits out the physical reality of the light conveying the image from the microscope to the eye.
It substitutes the messy delay of light with a perfectly clean, physically impossible mathematical stillness.
If projecting a clean mathematical grid is basically faking reality, it makes me wonder how humanity managed to measure planetary movement before XY coordinates were standard practice.
That's a great point, and the text actually dives into this by looking at Johannes Kepler.
Right, the astronomer.
It's a necessary detour to understand just how long we've been doing this. Kepler was trying to calculate the intricate orbits of massive planets like Jupiter and Saturn.
And to do that, you desperately need a fixed background. You have to measure movement against something stationary.
But Kepler didn't have the luxury of an abstract Cartesian grid hovering in the void of space. Instead, he relied on the zodiac signs.
Like Aries, Taurus, Gemini.
Exactly. He utilized those distant clusters of background stars as his absolute, unmoving framework.
Here's where it gets really interesting. The visual that the text paints of Kepler's methodology is incredibly vivid.
Oh, the cylinder analogy.
Yes. To make his calculations work, Kepler essentially conceptualized the universe as a gigantic fixed cylinder. Imagine a massive cosmic tube. The zodiac stars are painted on the inside walls of this tube, and the sun sits perfectly still right at the central axis.
And Earth is just swirling around inside.
Exactly. So when we look up at night, our sky simply intercepts the light traveling from those painted cylinder walls toward the center.
It is a brilliantly creative mechanical model for its time, but the text uses it to expose the same recurring flaw.
That Kepler's math only worked because he assumed a fixed, unmoving background.
Right. He treated the zodiac stars as completely stationary. It's the exact same illusion classical physicists fall for when they assume their abstract grids are stationary. The tool changes, but the false assumption remains the same.
Which brings us to the most explosive section of this deep dive. This is where the text points the finger at Albert Einstein.
Specifically targeting his special theory of relativity.
Right, and it claims he essentially slacked off on the geometry. And just as a quick reminder to you listening, we are neutrally exploring the arguments presented in this specific blog post. We aren't tossing out textbooks or declaring established physics null and void here.
We are just thoroughly unpacking a highly provocative thought experiment.
Exactly. We are just the messengers.
And that context is crucial because the claim is undeniably bold. The text's main grievance with Einstein centers on his famous thought experiment involving a moving train.
Right, the classic relativity example.
In formulating special relativity, Einstein declared that the speed of light, the constant CO, is the same in all directions inside a moving inertial frame, like a smooth-riding train car.
And the post argues that this is a mathematical contrivance. It actually calls it forced logic that willfully ignores how light's apparent speed looks to someone standing outside the train.
If we connect this to the bigger picture, the piece actually compares Einstein's approach here to Ptolemy's epicycles.
Ptolemy, the ancient astronomer who insisted the Earth was the center of the universe.
Right. When his observations of the planets didn't match his theory, he didn't change the theory. He invented insanely complex looping orbital paths called epicycles to force the math to fit his flawed assumption.
Wow. And the text is aggressively levying that same accusation at Einstein.
Yes, suggesting he manipulated the mathematical definitions to keep the speed of light constant, rather than respecting the physical geometry of how light behaves.
Hold on, I want to make sure we get this right. To back this up, the text pulls from history again, bringing up James Bradley's discovery of stellar aberration.
Which sounds like dense astrophysics, but the analogy provided is surprisingly everyday.
It is. Imagine standing on a moving Earth, aiming a telescope straight up to catch light falling directly down from a star. Because the Earth is moving beneath the starlight, you actually have to tilt the telescope slightly forward to cast the beam down the tube.
The Post likens it to running in the rain. You don't hold your umbrella straight up, you tilt it forward so you don't run into the raindrops.
That tilt represents the physical reality of observing light while in motion. And there is a pivotal image in the source material titled "The Reality of Slanted Light Paths" that really forces this issue.
Right, let's picture a neutral observer standing outside Einstein's moving train.
The text visualizes this observer as a Wimbledon tennis umpire.
Sitting perched up high, perfectly still at a coordinate off to the side, say y equals -10.
Okay, I'm picturing the umpire high up in the chair. Now, a beam of light shoots from the ceiling of the moving train down to the floor. To the passenger standing inside the train, the light drops straight down.
But the umpire outside doesn't see a straight vertical drop. As the light falls, the train floor is simultaneously moving forward.
So to hit the same spot on the floor, the light beam has to travel a longer, slanted, diagonal path from the umpire's perspective.
Exactly. The geometric argument made here is that if the light traverses that longer diagonal distance in the exact same 1 second, its apparent speed to the umpire must exceed the universal speed limit of light.
And the Post claims Einstein noticed this discrepancy and simply used abstract mathematical definitions to hand-wave it away.
Essentially slacking off instead of dealing with the messy physical reality of that slanted path.
If we accept the premise for a moment that Descartes, Newton, and Einstein all relied on faked, stationary grids that ignore the true behavior of light, how on earth does this Post suggest we map reality?
We still need to measure things.
Right, we can't just throw up our hands.
The proposed solution is a complete overhaul centered on a concept the author calls the camera eye.
The camera eye.
Instead of plotting objects on an XY grid, the argument is that we have to meticulously track the journey of light through a 4-stage framework based purely on information delay.
Let's walk through that, because a rigid 4-stage framework sounds a bit dense. How does this camera eye actually work in practice?
It requires shifting from thinking about where an object is to thinking about how its image physically reaches us. Stage 1 is the simultaneous departure of light from the physical surface of the subject we are trying to observe.
All right, so the light bounces off the coffee mug on my desk. What happens next? The text mentions a flat glass window.
Yes. Stage 2 asks us to imagine that light passing simultaneously through a theoretical flat glass window floating between the object and the observer.
Okay, so a checkpoint.
Exactly. It's a conceptual way to track the leading edge of the light wave as it moves through space. Then, Stage 3 introduces a spherical window picture, a transparent bubble with a radius of 1 that completely surrounds the camera eye, or the observer.
So the wave of light travels from the mug, passes the flat glass checkpoint, and hits that transparent bubble surrounding me.
Yes.
And the final stage is just the light hitting my actual retina, or the local focal point.
That's Stage 4, the simultaneous arrival at the focal point. But the overarching point of mapping it this painstakingly way is to highlight a glaring truth.
Which is what?
Because everything in the universe is in constant motion, light that leaves the subject surface simultaneously almost never arrives at the camera eye simultaneously.
The varying distances and relative speeds stretch and distort the information.
The image gets warped by the delay in the motion.
That's the logical conclusion the Post makes. It points to another key diagram titled "Remitting Physical Reality."
The argument is that we need to torch the Cartesian grid entirely. Forget the endless perfect squares of graph paper.
You need to replace them with light cones.
Right. A light cone is a geometric model that doesn't plot static locations. It plots the delayed arrival of the electromagnetic field to a specific local point over time.
It reimagines reality not as a frozen map, but as a dynamic, constantly flowing stream of delayed information.
Precisely.
So what does this all mean? Swapping graph paper for light cones sounds great in a university lecture, but how does this change our understanding of moving through the actual world?
The text uses a final example that I think really grounds this, a trip from Tokyo to Mount Fuji.
Okay, let's hear it.
It replaces the traditional spatial axis with a complex space-time axis. Normally, you look at a map and say Tokyo to Mount Fuji is roughly 100 kilometers.
The distance is a fixed, static number.
Exactly. But this new framework demands we describe that distance as the number of hours it takes to travel there, or more accurately, how long it takes a light signal to cross the gap.
And there's a massive twist here that requires a bit of mental gymnastics. We have to factor in that the Earth is spinning.
It rotates toward the east.
So Tokyo is constantly in motion, moving eastward. If you stand in Tokyo and shoot a laser beam westward toward Mount Fuji, that light beam has a literal tailwind.
To visualize this, imagine standing on a spinning playground carousel and tossing a ball to someone near the center.
Right.
Because you are rotating, the dynamics of that throw are completely different than if you were standing perfectly still on solid ground.
The destination is literally moving to meet the signal. Because Mount Fuji is positioned to the west as the Earth rotates east, Fuji is rotating toward the light beam emitted from Tokyo.
But if you reverse it and shoot the laser eastward from Mount Fuji back toward Tokyo, it's a totally different physical event.
The light faces a headwind.
Exactly. Because Tokyo is rotating eastward, it is physically spinning away from the incoming light signal.
So from that specific vantage point, the apparent speed of the light is slower because it has to catch up to a moving target.
The text argues that a genuine physics framework has to account for these shifting vantage points within the electromagnetic sea.
If you rely on the slacker mathematical shortcut of a stationary grid, you are falsely assuming the distance between Tokyo and Mount Fuji is identical in both directions at all times.
Completely ignoring the physical reality of the rotating observer.
To pull all these threads together, the ultimate takeaway from this incredibly dense piece of writing is a challenge to your perception.
A huge challenge.
The author wants you to stop putting your blind faith in the neat, perfect, stationary squares of mathematical graphs. They want you to visualize the universe as a swirling, chaotic sea of delayed light,
where the reality you perceive is entirely dependent on how fast you are moving and exactly where your camera eye happens to be positioned. This raises an important question, though. Setting aside whether the broader scientific community will ever validate this specific critique of Einstein, the thought experiment does something highly valuable.
which is
It forces us to confront how heavily we rely on abstract models to make sense of a deeply complex universe. We build these mathematical simplifications because the sheer volume of chaotic data in reality is simply too overwhelming to process without them.
which leads to a final, somewhat unsettling thought that builds right on top of that. Something not explicitly stated in the blog post, but impossible to ignore once you grasp these concepts.
What's that?
If our mathematical models create a fake stationary reality by ignoring the delay of light, doesn't the human brain do the exact same thing?
Absolutely.
Think about the room you are sitting in right now. Your brain is actively taking in light bouncing off walls, furniture, and screens at slightly different times based on their distance from you.
But it stitches all that delayed, chaotic information together.
Yes, to present you with a smooth, perfectly synchronized illusion of now. You don't just use Cartesian grids in a high school math class. Your own mind is generating a Cartesian illusion every single second, just so you can reach out and grab a doorknob without stumbling.
That is a profound way to look at it.
It is something for you to ponder the next time you look up at the stars or just across the room.